Hello class, we're about to start section 1.2 notes, graphing linear equations. We have our first objective, graphing linear equations by hand. A linear equation is defined as that it contains variables raised only to the first power, x and y. When graphed, the points that satisfy the equation form a straight line. Now, graphing the linear equation with the convenient point method. We have step 1. Solve the equation for y. Step 2. Choose convenient values for x to avoid fractions and decimals. And calculate the y value for each x value. Record results in a t-table. And then step 3. Plot your points and draw the line. Now we come down here to example 1. It says graph the line 2x minus 3y is equal to 15. Now remember, our first course of action is we want to get y by itself. So what we need to do here, we will write this equation again. We have 2x minus 3y is equal to 15. So we will subtract 2x on both sides. And we will have negative 3y is equal to negative 2x plus 15. Now we have to get y by itself, so we divide each individual term by a negative 3. These simplify out and leave us y. And we have a negative 2x over a negative 3, which will give us a positive 2/3 x. And then a positive 15 divided by a negative 3 will give us minus 5. So now we have y equals 2/3 x minus 5. Now our next step is we want to create a t-table. Okay, so we have our t-table and we have an x and y value here. As a matter of fact, let me see if I can make this just a little better as far as this line is concerned. Now, this is a little better, but still crooked. Okay, now what we want to do is use a convenient point. Now, to find a convenient point, first of all, whenever you have a fraction connected to a variable, you could always use 0 for x, because 0 will wipe this whole term out, because a fraction times 0 is still 0. The next thing we would do is look at the denominator. We would take the positive denominator and we will also take the negative of that denominator. So now we would substitute. So we would take, and I'm going to write this off to the side. We will have y is equal to 2/3 times 0 minus 5. We know 2/3 times 0 is 0, minus 5 is 5. So y is equal to 0 minus 5, which is a negative 5. Now, that is our first substitution. Now we go for our second substitution. We would take the same equation, but this time we're going to substitute in 3 for x. So now we will have y is equal to, these 3's will simplify out and leave 2, minus 5. So y is equal to a negative 3. Now we will go to our third substitution, and I'll write this over here. So we will still take the same equation, y equals 2/3, but this time we're going to substitute in negative 3 for x and minus 5. So we will have y is equal to, these 3's will simplify out, a positive 2 times a negative will give us negative 2 minus 5. So y will be negative 7. So these are our ordered pairs. We have 0, negative 5, 3, negative 3, and also negative 3, negative 7. So now we will go through and substitute. Oh, I'm sorry, not substitute. We will graph. So let's take these values here. We have 0, negative 5. So we will plot that point here. We have 3, negative 3. So we'll go 1, 2, 3, and 1, 2, 3. And then we will do negative 3, 1, 2, 3, and then negative 7. So we'll go down 7. So now we have our points. Now we can graph this line here. Now, of course, I don't have a straight edge, so my line may be crooked, but you can use a ruler so your line would be straight. So this should be a straight line. We'll draw our arrowheads to show that it goes on forever. Now, we're done with this problem. Now we're going to move on. Okay, now we move on to intercepts. The points where the graph intersects the axis. So right here, first of all, we must know our axes. So this right here, the vertical axis is the y-axis. The horizontal axis is your x-axis. Okay, now, when a graph crosses the y-axis, that is considered to be your y-intercept. And then when a graph hits the x-axis, that is your x-intercept. Okay, now, the ordered pair representation of these intercepts goes like this. Whatever intercept you have, which here is the y-intercept, the other value is 0. So we know x always comes before y with any ordered pair. So with your y-intercept, x is 0. Now we're going to use b to indicate that this is the y value of your y-intercept. Now for your x-intercept, again, x is first, y is second, so y would be 0 here. Now we're going to use a to denote your x-intercept. So your y-intercept is 0, and then whatever value y is. And then your x-intercept is whatever x is, and y will be 0. So now we come down here. It says graphing a linear equation with the intercepts method. Find the y-intercept, substitute 0 for x, and solve for y. Find the x-intercept, substitute 0 for y, and solve for x. Plot your points and draw the line. Now let's take a look here. Let's apply what we just read. Let's find the y-intercept first. The y-intercept tells us we must substitute in 0 for x. So we would take 4 times 0 plus 3y is equal to negative 12. So 4 times 0 is 0, plus 3y equals negative 12. So you add 3y equals negative 12, divide each side by 3, and y is negative 4. So the ordered pair, you must write this as an ordered pair. So it'll be the y-intercept and that is equal to the ordered pair of 0, negative 4. Okay, so that is one of your points. Now we're going to do the x-intercept. Now the x-intercept, we're going to take the same exact equation, but this time we're going to make y 0. So we have 4x plus 3 times 0 is equal to negative 12. So we have 4x plus 0 equals negative 12. So we have 4x is equal to negative 12. Then we have to divide each side by 4. And x is negative 3. So your x-intercept is the ordered pair negative 3, 0. Because remember, y must be 0. So now we will plot these points here in graph. So we would take 0, negative 4, which is here, and then we would take negative 3 and 0. Now we will connect these points. Remember, it's supposed to be a straight line. I don't have a straight edge, but you do. So you could draw that as a straight line, and do not forget to put your arrowheads at the end. Remember, this is supposed to be a straight line. Now we move on to the next problem. It says graphing the special case linear equations. When the equation contains only one variable, so the other is missing, you have a special case. Now these special cases will form a horizontal line or it will form a vertical line. Remember, horizontal lines go straight across and a vertical line goes straight up and down. Okay, now the equation for a horizontal line will be y is equal to, it would be some number. So y is equal to some number. That means there's no x values involved. It's just y equal to a number. And then for the vertical lines, it'll be x is equal to a number. So that means that there is no other variable, just x, and it's equal to a number. And that will let you know that you have a vertical line. Now, we come here. The example. Example 3, it says graph the lines. We have y is equal to 6. So we go on the y-axis up to 6. And then what you would do is you would draw a line, because this would be a horizontal line. And it's supposed to be a straight line. Again, you have a straight edge. I do not. So this is our answer. Y is 6. Now we come here, x equals -8. So we go on the x-axis and we go over to -8 and plot that point. And then we draw a vertical line. Now I can go very far or you can make it short, but as long as it's a straight line with your arrowheads on it. Okay, now example 4. Remember, in order to produce an accurate graph, you want to avoid having to estimate fractional or decimal coordinates as much as possible. For each equation, decide whether it be better to use the convenient point method, the intercept method, or one of the special cases. Now, let's just take a look here. Okay, so we look here. We have y equals 5, 6x minus 2. Okay, now, since we have a fraction here next to our x, we will want to use the convenient method. So we will use the convenient method. Now we have x equals 5. We know that that is a special case. Now we have 5x plus 2y equals 20. This would be the intercept method. Okay, y equals 5/4 of x. Again, this is a fraction with our variable. We will use the convenient method. Y equals -6. That's another special case. And 3x plus 7y equals -21. We'll use the intercept method. Now remember, this is to help you more effectively do your problems, because if you try to apply the special case to the convenient method, you will have a hard time to go as far as graphing is concerned. Okay, now we come to our objective 2, a brief review of solving linear equations. Example 5, solve the equation. Now the first thing we have to determine is, what are we solving for? And as we can see here, we're solving for x. So we need to get x by itself. Now there was a problem here on example 5a. This -6.89 is supposed to have an x with it. I know it does not show up in your course pack. However, you need to add that in. Okay, now we want to get x on one side by itself. So why don't we move this -6.89x by adding it to both sides? We can add 6.89x. So what we would be left with is, this would be 3.68x plus 74.04 is equal to a -90.47. Now we would have to subtract 74.04 on both sides. We'll be left with 3.68x is equal to a -164.51. Now, again, to get x by itself, we divide each side by 3.68. And we will have x, and this will be an approximation. We approximate to one decimal place. It'll be -44.7. And that is our final answer.